Hi, in this video you're going to learn the laptop motherboard power sequence. Okay, so the power sequence is a mandatory thing that every technician should know. You know why? Because if you understand the power sequence, you can understand the working principle of any motherboard. This is the charge IC, as you can see. Okay, here we have the BQ24703. This is a charge IC. Here this is MOSFETs. Okay, these symbols means MOSFETs. This is also the part, the charge IC. Here we have, as you can see, the TPS51120. This is the power management IC for 3 volt and 5 volt always. Here we have two switches or MOSFETs. Okay, through this MOSFETs we will get 5 volt and plus 3 volt. Okay, and 3 volt will be converted via this switch to 2.5 volt. Here we have TPS51124 that generate 1.8 volt and 1.5 volt. Here, as you can see, this is the VCCP power management IC. It generates plus VCCP for the processor and the chips. And here, this is the Max 8770, the power management IC for the CPU. As you can see, it generates the plus VCC car. Okay, let's begin with the adapter. As you can see, we have the adapter. The 19 volt will pass. As you can see, this symbol means the direction of 19 volt will go through this MOSFET, and then the MOSFET will be activated by a control signal from the power management IC, the charge IC. Okay, then the 19 volt will pass to the current sense resistor, as you can see. So the current sense resistor, after that we will get the VBAT. Okay, this is the main voltage that will be distributed for the whole motherboard. The VBAT will distribute it to all circuits in the motherboard, as you can see. Okay, so the VBAT is a main power for every motherboard. After receiving the VBAT and the enable, as you can see, this IC will generate the 3 volt and 5 volts power rail. Okay, 3 volt and 5 volt are a very important voltages in the motherboard. Okay, so 3 volt always and 5 volt always. And these two voltages, as you see, will be applied to two MOSFETs or switches in order to get, as you can see, plus 5 volt and plus 3 volt. This is a normal voltage. Okay, then the 3 volt, as you can see, will be implemented to another circuit. Okay, as you can see, AM3446, and we will get 2.5 volt. Okay, so this is for the 3 volt 5 volt power circuit, of course, after receiving this enable signals. So also the VBAT will be applied to this circuit, TPS51124. Here also we have two enable signals. Okay, and we will get 1.5 volts, okay, and 1.8 volts. The 1.8 volt will be applied directly to TPS51100. This is another IC. So the 1.8 volt with these two enable signals will be applied to this IC, and we will get 0.9 volt for the RAM. This is a VTT power for the RAM. Okay, the RAM has two kinds of power, 1.8 volt and 0.9 volt, of course, for DDR2 RAM. The main power, the VDD power, or the main power, and the 0.9 volt or VTT, the half of the main power. So the VBAT also will be applied to the next IC, as you can see, TPS51117. This is plus VCCP power management IC. Here also we have an enable signal, power OK. So the enable signal with the plus VBAT will apply to the IC, and the IC will give plus VCCP to all chips, including the processor. The plus VBAT also will go directly to power management IC for the CPU Max 8770 or Maxim 8770. This is the CPU power management IC. Of course, here we have many enable signals, many signals. This is the ID signals. Okay, this is the ID signals. Based on these signals, about 8 signals, the IC will know the specific voltage for the CPU. Okay, of course here we have other signals, power OK, PSI, power management, as you can see. So after receiving the power bath and the enable signals and the IDs, here the IC will generate the VCC core through two channels, a main channel and a slave channel. Okay, so we will get plus VCC core, as you can see. So here, as you can see, we have batteries. Okay, so the battery need to be charged. Okay, so as you can see here, this is the charge IC. Okay, here we have the charge control from the East IO or Super IO. When this charge control arrives, here we have the EC OK. The charge IC will generate EC OK and also will generate this voltage. As you can see, this voltage will pass through two MOSFETs. The MOSFETs will be activated by the IC, and then as you can see, the battery will be charged. Now we're going to see all these ICs that we have seen in the schematic in a real motherboard. So we will begin with the BQ. We will begin with this IC, the charge IC BQ24703. So this is it. As you can see here, we have 24703. As you can see, this is the charge IC, as you can see. Okay, so this is the charge IC. So we will see right now the next IC, the TPS 51120, the IC that is responsible for generating 3 volt and 5 volt. So let's see it in the motherboard. So as you can see here, we have TPS, as you can see, 51120. This is the IC that is responsible for generating 3 volt always and 5 volt always. Okay, as you can see. Now let's see the power management IC of 1.5 volt and 1.8 volt. This is TPS 51124. Okay, so let's see also this IC TPS 51100 that is responsible for generating 0.9 volt for the RAM. So we're going to see these two ICs. So 51124 and 51100. This is, as you can see here, to 51124, as you can see in the right, and over here, as you can see, this is, as you can see, 51100. This is a power management IC that generates 0.9 volt for the VTT, the power, the RAM, the random access memory. So these two ICs, always you will find it near to each other. Okay, so now let's see the plus VCCP power management IC, the TPS 51117. So the plus VCCP will be applied to the processor and other chips in the motherboard. So let's see it in the motherboard. Of course, this IC should be near to the processor. As you can see, we have here the processor, as you can see, and we have here the IC. We have 51117, as you can see. So this IC generate plus VCCP for the processor and for other chips like the PCH or GMCH. This is a fuse. So now we're gonna see the Max 8770. This is the CPU power management IC here. It generate plus VCC core through two channels. As you can see, this is two channels here. We have two inductors. Each inductor means a channel. Okay, two inductors. So right now, let's see the power management IC. As you can see in the back of the socket of the processor, as you can see, this is the processor circuit. The back of the processor circuit here, we have the Maxim, as you can see, near to the socket. Maxim 8770, as you can see. So this IC is responsible for generating the power, the working power for the CPU, the plus VCC core.